Hello friends, let's continue with our series. In the lecture number 15, we will be learning about decision trees. Alright, let's begin. What is a decision tree? A decision tree is a supervised learning algorithm which is used for classification and regression tasks. It works like a flowchart where data is split into smaller groups based on feature values. Each internal node represents a decision based on a feature, and each leaf node represents an outcome or prediction. The tree is built by choosing splits that best separate the data, often using measures like Gini impurity or information gain. Features: it mimics human decision-making logic. It can handle both numerical and categorical data. It does not require feature scaling or normalization. Finally, it is easy to visualize and interpret. So friends, basically decision tree is simply a supervised learning algorithm. It is one of the supervised learning algorithm which is used for both classification and regression. Unlike the previous algorithm that we studied that were either only used for classification tasks or regression tasks, this algorithm can be used for both, right? So it basically works like a flowchart where whatever the data we have, this data is divided into smaller sections based upon the values or features, right? Then each internal node represents a decision based on a feature or a value, right? So it will tell you about a decision that it has concluded on the basis of its features or values. And also once each leaf node each leaf node represents an outcome or prediction, right? Any leaf node you see, it's just an outcome, just a prediction, that's it. The tree is built by choosing splits that separate the data, often using measures like gene impurity and information gain. So using these measures, the data is being split, and the tree is built by choosing the data that is split, right? So as we saw, some of the features are it can mimic human decision making, so it can basically think like a human, you know, and then we know that it can handle both numerical and categorical data, right? That is basically exactly how it is able to do the regression, do the classification tasks and those kinds of stuff, right? Okay, and it does not require feature scaling or normalization, right? It does not need any of those additional features. And finally, it is easy to visualize and interpret. And when do we use decision trees? Decision trees are great for simple models, quick prototyping, and when model interpretability is important, right? So these are great when the model is simple, you have a quick prototyping demand, and when model interpretability is important. Those are things matter for decision trees, and they are especially useful when the data has non-linear relationships or mixed data types, right? Solving the problem that the previous algorithms were not able to do as efficiently. uh, then we have some limitations, which are it can be prone to overfitting, especially with deep trees. mm. We will learn more about overfitting and underfitting later. For now, just read and try to understand. It is prone to overfitting, right? So the model is in such a way that it allows and exposes itself to the overfitting problem of machine learning, you know. And it happens especially with the deep trees, and It can be unstable at times, meaning small changes in data may lead to different trees, and that is very understandable. Finally, it doesn't perform well alone on very large data sets, better in ensembles like random forest, right? So, it's not the most optimal thing to be using when you have a larger data set, right? Alright, that was it for this video. I hope you were able to understand. Thank you for watching.